In this video, we're going to discuss the OSI model. The OSI model stands for the Open System Interconnection model. The OSI model is a 7-layer model that describes how network systems communicate with one another. It's basically a roadmap from the IEEE that tells different networking vendors how they can interact with one another using standard terms and standard functionality so that you can get a network card from Dell, for example, and connect it to a Cisco switch, and you know they're all going to work together and you don't have to have all Cisco hardware from one end to the other just to run your network. The OSI model looks kind of like this. There's 7 layers, and there's a couple of acronyms you can use to remember the different layers of the OSI model, depending on which direction you want to go with this. Going from layer 1, it's please do not throw sausage pizza away. Going the other direction, starting at layer 7, it's all people seem to need data processing. The more creative among you can probably come up with some other acronyms to go along with the OSI model. But if you're going to do any networking, any serious networking at all, you're going to learn this and love this and know it, and you're just going to know it cold. Now, we're not going to get into a whole lot of depth about the OSI model at this level, at the CCENT. If you're truly interested in the OSI model, there's dozens of web pages that go as deep as you want to get into the OSI model. But at this level, we're just going to cover what it is, what the different layers are, how they interact with one another, and that's pretty much about it. So we'll start with a very high-level understanding of how the traffic gets from one end to the other. Basically, the traffic starts up at layer 7 at the application layer. I'll go back a slide here. It starts up here at layer 7, and as it's passed down each of these layers, each layer adds its own headers to identify the data at that layer. Here's a very crude drawing of what a network packet would look like. Up here at level 5 through 7, that's where your protocols reside, your HTTP, DHCP, DNS. When it gets below layer 5, it goes to layer 4, you're talking about TCP. You get TCP headers at this point, so the packet just gets bigger and bigger and bigger the closer you get to the physical layer. Obviously, the physical layer is what we'll cover first, and there's not really any protocols at the physical layer because it's physical. It's wires and cabling and whatnot. And that's a perfect segue to talk about layer 1, the physical layer. Layer 1 controls the physical aspects of data communication across the network. Things like cabling, connectors, voltages, the type of media, whether you're using copper or fiber, the type of termination. And the things you'll see at the physical layer are hubs. They're basically Ethernet repeaters. They see electricity come in on one port, they send it out all of the other ports. Obviously, the other thing you'll see at the physical layer are the network interface cards that go in your PCs and your servers. At this layer, the transmission is all either light if you're using fiber, or it's electrical impulses on copper wire. That's basically all you've got at layer 1. Layer 2 is where things start to get interesting, in my opinion. That's the data link layer. Data link layer controls communication on the same local network. The data link layer also controls access to the physical media through various mechanisms, and we'll get into how that works when we talk more about how Ethernet works elsewhere in this course. The data link layer also performs error correction on transmitted frames. It can tell if a frame is corrupted in transit and will request that frame be sent again at layer 2 before any of the other higher level protocols have to try to reassemble that frame and determine later on up the stack that, oh, this frame is corrupt, resend the whole thing. Layer 2 addresses are physical addresses. These are the addresses that are burned into your network card. It's the MAC address if you've ever looked at the ipconfig output on a workstation. And again, since layer 2 is really only concerned with local area networks, those MAC addresses have to be unique, just like every address has to be unique. The OSI layer 2 data link layer is technically split into 2 sublayers: the LLC layer, the logical link control, and the MAC, or the media access control. Again, we're not going to get into that in this course. All you really have to know is that they exist in order to pass the exam. Switches and bridges operate at layer 2. Remember where we said hubs operate at layer 1 because hubs are just dumb repeaters. I see electricity come in, electricity goes out. Switches and bridges actually look at the MAC addresses, the layer 2 addresses in the Ethernet frames, and they will say, oh, well, I see that your destination is this MAC address, so I'm only going to send that packet out the one port that's connected to that MAC address. The types of protocols you'll see running at layer 2 are 802.3 Ethernet, obviously, HDLC at SDLC, PPP, PPPoE for wide area networking protocols, and your good friend CDP, or the Cisco Discovery Protocol. Now, we'll get into that a little later when we start to use some of the routers and switches in our lab, CDP can be your best friend when you're trying to troubleshoot network connectivity issues. CDP runs at layer 2 and will tell you what's connected on what ports in your router or your switch. We'll pick up with layer 3 in the OSI model in the next video.